So we're now going to start our discussion of another case study to illustrate parallel streams. This case study is what's called the Parallel ImageStreamGang case study. And you can get the case study here at this link at my GitHub repository. So we'll start by kind of giving an overview of how this case study works. And we'll also talk about some of the strategies for understanding its object-oriented and functional design and implementation. It's a pretty big project with lots of really cool pieces. And we won't go through all of the cool pieces, but I want you to at least be able to understand how to approach large software systems to make sense of them. And this will include thinking about some of the patterns that are involved in guiding the design and implementation, so the data flows, which we're going to visualize, and then also, of course, we'll look at the code, which is really the ground truth. But as always, just looking at code itself can be daunting at first, so these other techniques are very effective to try to get a bird's eye view of what's going on. By the way, does anybody know what this painting is? Or actually, it's not a painting. I think it's an etching. This is famous work by M.C. Escher called The Three Worlds. And it's kind of cool because it's showing like the ground and the water and then the reflections in the water. So it's kind of giving you different perspectives in one diagram. So let's first start by talking about what this project is. And basically, this app combines parallel and sequential streams, completable futures, and reactive streams using a framework, which I call the StreamGang framework, in order to make it possible to download, transform, store, and display images. And there's a couple different variants of this. One uses an Android app. Another uses a command line version. They're more or less the same code. And so we're going to take a look at this. And what's cool about it is we can take a look at it from a couple different perspectives. Right now, we're going to talk about it from the point of view of parallel streams. But then later, after we've talked about completable futures, we'll come back and review it from that point of view. And then later, after we talk about reactive streams, we'll come back and look at it from that point of view as well. What's also cool is you can do an apples-to-apples performance comparison showing which of these different strategies works the best under different circumstances. As you probably know by now, parallel streams must use the Java fork join pool, in particular the common Java fork join pool. And as we'll talk about later when we get into it, completable futures may use the Java common fork join pool, or you could use a custom fork join pool, or you could use some other completely different type of concurrency model altogether. And that's one of the things that makes completable futures very powerful, is you can customize the way in which threading is applied to that framework. So here's how this thing works. So if you're using the Android app version, it prompts the users for URLs to download. So you can kind of type those things in. And once you've given the URLs to download, then you go ahead and click the download button. And it goes ahead and it downloads the images that you requested. And those are then transformed. And we'll talk about that in a second. So the images are downloaded. So we download the image. Then there's a list of image filters to apply to transform the downloaded images. So you might apply the grayscale filters. So you'd go from having color versions of everything to gray versions of everything. That, of course, takes computation time, so motivating the need for parallelism. And then after the images have been downloaded and transformed, they're then stored in persistent storage on the local Android device. Now, if you're using the command line version, obviously it stores on your local command line. So that's basically the way things work. This should look very familiar because it's very similar to your image crawler assignment that you've been doing, but it uses a slightly different set of techniques. It also is cool because it applies a whole range of modern Java features, such as the ones described in the Modern Java in Action book, which I highly recommend if you haven't got it already. So there's support, for example, for sequential and parallel streams, and we're going to focus on parallel streams right now. And in a nutshell, what happens here is we get the input, which is this list of URLs, and then we convert that list of URLs into a parallel stream of URLs. We're going to get rid of images that have already been downloaded and processed. We're going to skip the ones that have been cached. We then take the ones that have not yet been cached, and we download them from our remote web locations, web servers. We apply the filters to transform the images, and then we reduce and concatenate the results. And we do it this way in order to be able to maximize the use of parallel streams. A more intuitive thing to do here would have been to apply flat map, but sadly, flat map doesn't work properly in the context of parallel streams. And then when we're all done, we collect the results up into a list, and those are stored in a list of images that have been downloaded and transformed and stored. And then that is handed off to another activity in Android to display them in a gallery-like view. What's cool about this particular approach, by the way, is how intuitive it is once you understand streams to read this at a higher level. You can kind of read this almost at the level of the intent of the design, rather than getting wrapped around the axle of implementation details. There's no looping, there's no conditional statements, there's no switch statements. You can just kind of read it in a linear way from top to bottom, and everything gets parallelized along the way. There will also be a completable futures version of this stuff, and what this will do, I will not spend a lot of time on that because that's not the focus of this lesson. But what we do is we take the list of URLs, and then we asynchronously check to see if they've been downloaded already. And for the ones that have not been downloaded, we asynchronously download them. And then we go ahead and we asynchronously filter them. And all that asynchronous computation runs in the background in various types of thread pools. And we collect the results into a group of completable futures. And then when everything is finally finished, we go ahead and basically print the results and get the final results come back basically as a list of filtered images, filtered and transformed and stored and so on. And what's cool about this is all this stuff takes place asynchronously. However, you'll notice that we use a Java sequential stream to give the overall design structure, which is kind of cool. We'll also talk about reactive streams. So that's yet another way of doing things. And this uses either Project Reactor or RxJava. You'll get a chance to play around with these technologies. And basically what we do here is we take the list of URLs and we turn them into something that's called a flux, if we're using Reactor, which is kind of a funny name, a flux reactor. And then we use something called the flat map concurrency idiom, which is a little different than flat map in parallel streams, although it's kind of along the same lines. But it doesn't suffer from the defect that the parallel streams version does, where it doesn't work for parallel processing. And then we go ahead and we take each of the URLs, and in parallel, we go ahead and download them and then apply the processing for all the pieces to filter and transform them. And then we do a reduction operation to put them all into a list. And you'll see that this version is actually a little bit more verbose than this version, but under some circumstances, it performs better. And we'll talk a lot more about that. We're going to cover completable futures and reactive streams later. This is just a teaser for that. Something else that will get used throughout the discussion, which we've talked about quite a bit, is the application of foundational Java functional programming features, things like lambda expressions and method references. And we like to use them in lieu of this crufty old anonymous inner class-like approach. This is the lambda expression version and the method reference version. This is the old school version doing the same thing using anonymous inner classes, which, as I think you'll agree, are painful to look at because they're so verbose. So, as I mentioned before, this is a complicated project. There's quite a number of classes. I don't even show all the classes that are in there now. Maybe I should see if I can find a way to diagram them all. But there's literally dozens and dozens of classes, and they interact in very interesting ways. And so it's therefore useful to analyze them from different perspectives so you get a better view of what's actually going on. And this is really not just intended to give perspective on this assignment, but to think more generally about how do you come at a piece of software that's non-trivial? How do you start to try to understand it? It helps in our case that I've used patterns to organize the relationships between these various classes, and we'll talk about those in a second. So that helps give you a gestalt, holistic view of the design. But there's also other things to think about as well. So we're going to have a bunch of lessons that go through this stuff, so you might want to go back and watch them to make sure you understand it. We're also going to spend time visualizing how the interactions occur. I particularly find that useful. Not everybody finds that useful, but I would rather get a bird's eye view visually when I'm first encountering a big piece of software, rather than just starting by diving into the code, which can be a bit daunting. And of course, reasoning the code to see how it all works is really the ground truth. That's where the rubber hits the road, as it were. So you might want to take a look at the source code. It's very cleverly written. It's very interesting, the design, and of course, it's heavily commented, so you can understand it, hopefully. Okay, so that's the overview of the ImageStreamGang case study, focusing primarily on the parallel version, which is what will be our focus for the next few lessons.